How can you validate the functional requirements of an embedded system with Stimulus? In this video we will look at how Stimulus can generate multiple test cases to simulate and validate system requirements, and how Stimulus can use an external graphical interface to provide domain experts with a deeper understanding of the specifications during the simulation. You should watch the video on Stimulus and its operating principles before watching this one. We will use train signaling as an example and look at two requirements. The first is the requirement for cancelling signals in front of the train. Up to 3 signals can be cancelled, except those after a red or stop signal. The other requirement covers the emergency brake, which is triggered if a train gets too close to the preceding one. Within the Stimulus model, there are 3 blocks. The train block, which represents one or more trains on the track and that generates the emergency brake message. CBTC ground produces the message cancelling 1, 2 or 3 signals in front of the train following the cancellation rule. Track automatically generates different track configurations, creating as many test cases as are needed for the validation of the train control system requirements. Train contains the CBTC board, which in turn contains the requirements specifying how the emergency stop message is produced. Initially, the emergency brake signal is set to false. Then, if the safe distance between the trains is too small for the speed at which the train is travelling, the emergency brake has to go true. Otherwise, it remains false. These requirements use operators labelled in natural language. The operators encapsulate the precise definitions, which can include equations or state machines. The key is that the requirements are very simple to read, and their semantics, defined elsewhere, are precise and shared by all Stimulus users. Let's launch the simulator. We set the simulation step to 10 seconds and do some sets of 10 steps. This curve shows the position of the first train. The other curve shows the second train. At this point it slows down and its emergency brake signal changes to true. We could go on with the simulation, but to make it possible for domain experts to see the results of the requirement and so allow them to provide validation, it can be useful to connect a GUI or graphical visualization tool from outside Stimulus. To connect to a GUI, we close the simulator and drag and drop the package Signaling System Visu. This contains a wrapper that encapsulates and calls the DLL of the GUI, which is enough to connect with the external code. We will do one step of a simulation. Stimulus starts by generating a track configuration with green or red signals positioned in different locations. In other words, we generated a test case which corresponds to what the railway team would call track data. Moving on in the simulation, this curve shows the progress of the train, which is also appearing in the graphic interface. The first 2 signals are cancelled, which is what we would expect from the natural language requirements. This variable represents the state of the third signal, the next one that the train should cancel after passing the first 2 signals. The cancellation state of the third signal goes through, and this can be seen in the visualization. As the simulation progresses, the specifications modelled in Stimulus behave according to the rule for cancelling signals. At this point, we see in the simulator view that the emergency brake is activated. In the visualization, a red mark shows the train is braking. Scenarios generated during the simulation can be exported to an Excel spreadsheet where they can be used for further analysis. The scenarios can also be used as test vectors for verification. We will now reinitialize the simulation session and generate a new track with a new signals configuration. In fact, Stimulus has produced a new test case generated randomly within a predefined set of constraints. If we reinitialize again, Stimulus generates another track configuration, creating another new test case that can be used to validate requirements. To see which constraints these test cases obey, we will look in the track generation package. It includes a few phrases in the language of Stimulus that perform a predefined number of iterations, that define the position of the next signal. It must be at least 2 kilometers from the previous one and be less than 100 kilometers from the beginning of the track. The signal aspect, whether red or green, is not defined, so stimulus will randomly choose red or green. You could, of course, put more constraints on the rules for track generation. The principle remains. You specify what constraints you want to place on the system or on the scenario, and stimulus generates as many test cases as you want, each complying with the constraints you have defined. To summarize, requirements and their test scenarios can be described in stimulus and validated through simulation. Stimulus can easily generate as many test cases as you like. You define the constraints on the test cases, and stimulus generates them automatically. Finally, you can easily connect the stimulus simulator to a graphical interface. This will be animated during the simulation, making it easier for domain experts to validate the specification. If you want to learn more about stimulus, please contact ArgoSim.